So thank you all for joining us for the Overcoming Statistical Anxiety, a Beginner's Approach workshop. Today, our two presenters I'll have them go ahead and introduce themselves, and then we'll begin the discussion on how to overcome statistical anxiety, data cleaning, outliers, descriptive statistics, Excel charts, and much more.
Hi, everybody. Thank you for joining us. So this is only the second time giving this presentation, so please, we encourage you to give feedback at the end of the presentation so that we can improve for next time. But today we're going to discuss several topics with regards to statistical analysis and research design. And the purpose is really to provide an overview of statistical anxiety, and tips to start when feeling stuck from fear. Okay, and here are our agenda items. We will provide a bit of bio information about ourselves and more at the end of this presentation. We will give you a broad overview about statistical anxiety and related variables as reported by a recent meta-analytic report. Miguel will review the research process and exploratory data analysis, and we will each cover the pros and cons of common statistical software packages such as R and SPSS. Okay, I'll turn it over to Miguel.
Hello, everybody. Thank you for coming. I can recognize some names in the chat, the participants, so that's cool. So I'm Dr. Miguel Fodolig. I am a tenure-track assistant professor at the UNLV School of Public Health. So I teach Intro to Biostats as well as other statistics electives. I got my doctorate in statistics and master's in physics from way back. I've been teaching at the UNLV for 3 years now. This is my 4th year. And Joanne?
Yeah, hi. So I have a doctorate in experimental psychology, a master's in industrial organizational psychology. I'm more of a teaching-focused professor, so my title is faculty in residence. I also have over 10 years experience teaching statistics and research design for both graduate and undergraduate students. And on the side, I also consult with regards to data analysis and research for organizations, both within and outside academia. Okay, so the following questions are from a validated scale for measuring statistical anxiety. The questions are just 5 example items from a total of 51 items from the original scale. So I will give you a few moments to take this time to take out a sheet of paper or just jot notes to respond to these questions, just to gauge for yourself how much fear you have about statistics. So your answers are for your purposes only. So you do not have to share them later or during the Q&A session if you feel it's something that you would, unless you feel like it's something you'd like to address. So I'll give you a few minutes to answer these questions. Remember, 1 is no anxiety and 5 is strong anxiety. So the domains covered by this statistical anxiety rating scale are a few. So what influences the magnitude of statistical anxiety includes 1, perceptions of the ability to understand statistics, 1's perceptions of the ability to solve a math problem or anxiety experience when doing so, anxiety when asking for help, anxiety felt when interpreting data, anxiety about having to take a test or exam, and fear of statistics teachers. So of all these domains, the few domains that causes the highest anxiety are being administered exams, attending class, and interpreting data. Therefore, statistical anxiety is measured from a variety of angles. A meta-analysis performed in 2022 reported a variety of predictors of statistical anxiety. So one of the predictors is actually self-awareness, which not only entails being aware of statistical anxiety, but also how one's personal tendencies may worsen this anxiety. For example, worry, tolerance, and uncertainty are related to statistical anxiety. If you identify yourself as a perfectionist, for example, this may lead to stronger anxiety because this trait causes you to set hard to reach standards, which ultimately causes heightened fear to the point of debilitation, which may lead to procrastination. Therefore, setting realistic goals will improve your ability to reach them, which will in turn steadily increase your confidence in data analysis tasks. So, to be clear, some of these tendencies, such as perfectionism and worry, may have served you well in the past and allowed you to become accepted into the graduate programs that you are in now. But given the rigor at this higher level, and because of the autonomous work required from you, there are strategies to help prevent those habitual traits from achieving success. So, to overcome that sense of worry, experts believe that deep breathing exercises may help. One popular breathing technique is a 4-7-8 breathing technique, and you can try to follow it now as I explain it. So, it includes taking a breath in 4 counts, like you breathe in for 4 counts, you hold for 7 counts, and then you release for 8 counts with a whooshing sound. So experts believe that doing this 4 times and gradually increasing the reps can help you feel a little bit more calm as you execute a daunting task. This specifically helps engage the vagus nerve to calm the nervous system. So another technique is a square box technique, and this is very common. So you breathe in, hold, breathe out, and hold in equal counts, just like a box, for 4 seconds each for several minutes. So that's a technique that's easier to memorize. Another technique in managing your worries is to use expressive writing in a journal to help write out your feelings and thoughts so that you can be more aware that the feelings and thoughts are impermanent and fleeting. So you need to remember that you're not your thoughts and feelings, and you have to allow your mind to process the stress in its own way. And this is the important part, without judging yourself. So it's important to take it in, but try not to judge yourself or be self-critical. And during the writing process, you can work on cognitive reappraisal training to reinforce the notion that anxiety and certain level of discomfort is completely normal. This means that stress is okay. Stress can be a motivator to help us get out of the rut that we feel in right now. So if you find that these mental health strategies are not working, you can also visit some of the experts we have here. So we do have the UNLV counseling and psychological services, so that you could be assigned a counselor who could help you with anxiety reducing strategies. And also there's the Academic Success Center, which have counselors to help you with skills such as time management. So I'll go ahead and leave it to Miguel to review the current process.
So thank you, Joanne. So most of you who are here probably have had a traumatic experience with statistics before. So what the current process that you go through is you first collect the data. It could be primary data collection when you collect the data on your own, or you search for available data sets online or from other principal investigators out there that might have available data sets for the project that you want to do. Or some of you in the hard sciences could have done simulations, and that is a different beast of its own, but suppose that you got through that. Now you would have to organize your data. And for primary data collectors, you have to enter it on Excel or an SPSS, right? And you have to encode these data on your own. And that is a tedious and overwhelming process. And then after that, what about when we have missing data? Do we need to clean the data up? Is it formatted weirdly, right? These are problems, especially for using available data sets. Sometimes they just don't clean it, and you're left with that responsibility. Also, you have to create code books for this data. At this point, you could see that it can become overwhelming. It just adds up. So what do you do when you actually have to analyze the data? You probably have used up all of your capacity and you just panic. When you have, or what test do I use? Am I doing this right? What assumptions do I need to do? So that's where the panic sets in and you just paralyze because you overanalyze too much. So the next slide will show you what you can do, and that is data exploration. So it is important to know what you're dealing with, to know how you're going to deal with it. So like a Sun Tzu quote is like, know thy enemy and know yourself. In 100 battles, you will never be defeated. So you have to first know what you're dealing with. So the data entry, it's good to have a lay of the land of what you're going to encounter, right? Or what you're trying to analyze. And then go through like what the analysis should be. And the next slide, what does data exploration ask? Or like what do you ask during data exploration? So what do your scores represent? Is it a yes, no? Is it a Likert scale from 1 to 5 or 1 to 7? Is it a measurement that is ratio? Is it height, weight, right? BMI? Now, after that, you look into what type of scores are you collecting? Are they categorical? Are they continuous? Um, and after that, if you have your research aims, are there groups that you expect to differ based on foundational concepts or theoretical backgrounds, right? Alongside that, what variables do you think are associated? So if one variable increases, the other decreases. For example, just age and bone strength. You expect them to be correlated based on previous studies, right? And so what we're actually doing here is we're looking at the data and we're looking back at foundational concepts of your field. And then you go back and forth, where like you're dipping your toe into something unknown and then you're coming back to something that you know. So it's not all statistics all at once. And then in that note, what are the guiding theories behind your hypotheses? We should work from there and then inform the analyses from there. Then lastly, if you feel unsure about yourself, you can communicate this to diverse listeners. So you can communicate it to your peers, to your friends in the simplest way possible, or your advisor or other faculty members in your committee. So next slide. So exploratory data analysis, we can answer all of these using 5 specific methods. So data visualization is one thing. So I know that most of you have had experience with statistics, and it's all numbers. It's all, yeah, p-values, confidence intervals, z-scores, t-scores. But one thing that's commonly overlooked is actually data visualization. A lot of people that we help are visual learners. And so maybe plotting or making charts of your data can help you understand what's going on. Other things that are pretty common are descriptive statistics. So mean, standard deviations. These are pretty basic things that people use in papers to describe their sample or to describe their target population, right? And then trend detection, I'll skip to trend detection. Do we see any trends? So seeing meaning based on descriptive statistics and data visualization. You could see sometimes that there are groups that have higher means than others or higher standard deviations than others. And you can see trends in scatter plots or line plots where you see a line that goes up or goes down, right? Is that something that you're expecting? And one of the things that could affect that is the presence of outliers. Are there extreme values in your data that you think can be accounted for or can't be accounted for? Is it an error? Did you rely on an undergrad research assistant or even a graduate research assistant who's new and didn't know how to encode data, right? So that's one thing that you can look into. Now, another type of abnormality that you could see in data is missing data. Some of you in the primary data collection, now who have experience with primary data collection could attest to this. Sometimes people just forget to fill out survey items, or you just don't see them again in longitudinal study designs, right? So it helps you too. Like, is this enough for an analysis, a formal analysis? Do we just want to show what we currently have, right? Maybe we stop exploration, we stop at exploration and not go to more advanced statistical methods. And so in the next slide, we're going to talk about how to explore data. So, well, not how, but what software you're going to use to explore data. So these are just two out of many. There are other softwares like SAS, Jump, Python, right? It really depends on where you're, like what you're working in, or where you're working at, what field you're researching in, and so on. So I'll talk about R software. So R is a free open source programming language, which is why I like it. And it looks like this in the right side of your screen. But unfortunately, R doesn't look like this. It's not beginner friendly, and so we use an interface compiler called RStudio. So the language that you're seeing on the right side is R, but the compiler and the interface is called RStudio. So both of these are free, which is nice because I know it's to buy a license for something isn't really a luxury that some of us could afford during grad school. Next slide. Now, what are the pros of R? R is very versatile, especially with data management and analyses. So it's crowdsourced. So a lot of people around the world are working on the same things that you are. And so chances are, if you have a problem, somebody has probably solved it for you. And it's highly popular among employers because it's free and because it's versatile. And did I say it's free? Yes, it's free. But the cons are you need to learn a new programming language. So people sometimes come in and say, oh, I have experience working with SAS or Stata or Python. And if you want to learn R, you need to learn R. So learning a new programming language is very similar to learning an actual language. Sometimes it's natural for you, sometimes it isn't. It is also slower than other programming languages, so people in STEM or computer science would argue that R is not a good software because it's slower in terms of processing. But it's so much better than the others compared to, for statistical analysis and data management. But if you're needing something that's more computational in nature, then maybe that's not the right programming language for you. And along that end, if you're trying to learn R, there's going to be an adjustment period to learning how to program. And knowledge of different packages, like I said, it's crowdsourced and everybody has their own packages in the repo. You probably would have to know which packages you need, and it's very tailored to a specific task or a specific analysis that you want for your data. And I think, Joanne, SPSS, right?
Our resources.
Our resources, right? So these are some resources that you can look into. You can take a screenshot or take a picture of this page if you want to. You have hands-on programming with R and Swirl. So these are beginner R. And if you really want to look into other books of R, it is compiled in this link called Big Book of R. So for every field, they have their own books, and you can just click on whatever you're interested in. R4DS or R4 Data Science is very good when it comes to data manipulation. So how are you going to clean data? How are we going to define new variables based on the current data? And there are others for statistical modeling and data visualization. All of those are helpful in exploring data using R. And now for SPSS, Joanne.
Okay, so I'll take over SPSS. So if I had not mentioned it before, I'm from the psychology department. And throughout my whole training in psychology, all my mentors had to use SPSS. And it's only until recently, maybe the last 5 or 6 years, where our department at UNLV had started transitioning to R because, again, as Miguel had said, it's easier. Not easier, but it's free. It's easier to access because it's free. SPSS, however, is a little bit different, and it's only available through licensing. But you can access it through the university at a discounted price. So just go to the IT UNLV webpage, and you can see that it's part of the software list where you can get it at a reduced price compared to if you were not a student. And if you use it privately or for other projects not related to the university, you will have to pay for it for like full price. From the last time I looked it up, it's about $99 a year per user as a base price. And that includes data preparation and bootstrapping. And any add-ons are about $79 for custom tables and advanced statistics users like regression, mixed models, etc. And another $79 for even more complex packages. So you could look into that to see what level of SPSS you need. For grad students, you probably just basically need the base app right now, the base format. And you could ask your mentors or your lab if they would purchase the extra add-ons for you if you need to do more complicated types of analysis. But basically, it's used by a variety of disciplines aside from social sciences. And unlike R, there's really no need to write complex code. So you could see from this diagram here, it's very different from the interface that Miguel had presented to you earlier. This is basically called a point and click method because you just point to the variable that you want, click on it, and move it to the box that you desire it to be under. So you have the dependent list box and the factor list box, and you have a variety of buttons here that you could also click to adjust settings. So much easier than R and very user-friendly. So I'll go over the pros and cons in the next slide here. So the pros of SPSS includes relatively ease of use, definitely for beginners of data science. I found it to be very helpful to learn SPSS as I was learning statistics. And it just made learning statistics a bit easier because I didn't have to deal with the coding that I would have needed if we used R. And as I said, because of it relies on the point and click method as opposed to coding. And it's still used by many universities and research organizations. So SPSS is still considered a serious application that researchers can use to get publications. And as I said, it's free. So it's free it's provided by UNLV. However, the cons is, the cons, as I said, it's expensive. And you may not be able to run advanced statistical procedures or produce sophisticated graphs without those add-ons. And another thing is that it's harder to rely on syntax in R, in that in R, you are creating a script that in essence can be rerun on a different data set with ease, right? So you don't even have to remember exactly what the details of the script were. You just have to have a script ready, knowing that that's a script you need, for instance, for like a confirmatory factor analysis. And once you have it on hand, you can use it for any future data or projects. For SPSS, it's a little bit harder to replicate that script. There are more steps to replicate it. For example, I remember I had to click paste every time I had, before I executed a particular action or task, I had to remember to click on paste so that SPSS could copy all that code into a different file. And also, if you really get good, you're less flexible. This means that once you get comfortable with SPSS, it's really easy and it's really hard to transition to R if you need it. So R is good in that once you learn a computer language, it's a little bit easier to learn another one. So if you need to learn Python, it's actually easier. It's sort of like learning a language in itself. Like once you learn a foreign language, it might be easier to learn another foreign language because you can see the patterns that exist when learning different languages. And the resources are out there. And the resources are out there mainly because older researchers have been out there for a while. They have worked with SPSS for years and years. So there is a good chance that if you're in the social sciences field, your mentor is only comfortable with SPSS, and that's the application that you'll work with when you analyze your data. So aside from your mentors, you have online resources such as easy SPSS tutorials. There's also Andy Field. He not only has an SPSS book, but he also has an R book, and I found his book's pretty helpful in breaking down the statistical analyses. And we have SPSS Statistics for Dummies, of course, and there's IBM SPSS Statistics books that come out every once in a while. They just update their books every few years so that they could keep up with the newer analyses that are in the newer packages. And as I said, it's pretty much common knowledge among experienced social science professors. So there's no shame in using SPSS, and a lot of people find that they'd rather do something easier and focus more on the literature part and the discussion part rather than finagling with a lot of codes that they would have to do if they used R.